Welcome to Project Hyrax. This project was developed for the Network Optix Hackathon to demonstrate how a web-based integration can collect and visualize geographic data within the Network Optix Desktop client. Project Hyrax leverages the Network Optix development toolkit, specifically using the AI Manager for object detection, a post-processor that converts bounding box coordinates to latitude and longitude, and the JavaScript API of the Network Optix Desktop client to manage devices and display them on the layout. Let me demonstrate how it works. We have two test cameras playing pre-recorded footage provided by Network Optix for the hackathon. While we're using a YOLO model specifically trained for this footage, any video could potentially work with the system. If detection accuracy becomes an issue, alternative models capable of object detection, classification, and bounding box generation can be substituted. Looking at the object's view, you'll notice that both bounding boxes and geographic coordinates, latitude and longitude, are displayed on the video feed. To enable this functionality, we configured the preprocessor properties by mapping points on the camera stream to their real-world coordinates. For this particular video, we identified the location as Interstate 75 in Atlanta, with the camera pointed at the Cumberland Boulevard Bridge. The post-processor requires 4 reference points to function properly. For best results, we selected fixed objects such as signs and poles as reference markers. Center of the box is used as a reference point. Once configured, the post-processor sends data to both the Network Optix video server and the Project Hyrax integration. To use this system, you'll need to add Project Hyrax as an integration and launch it. The Project Hyrax interface currently displays 2 devices, one without data, as it lacks an enabled AI Manager post-processor, and another with active data collection. Users can open a device directly on the layout from the Project Hyrax UI, which is useful for managing AI Manager settings, post-processor configuration, or other device controls. To visualize collected data, users simply click on a device tile, which launches a Rerun I/O interface displaying the recorded data from the camera. Due to peculiarities of the integration with Rerun.io, the Rerun view will initially replay all data collected since the launch of the Project Hyrax server that hasn't yet been visualized. In this visualization, vehicles appear as color-coded dots, green for cars, yellow for buses, and red for trucks. Project Hyrax demonstrates how data can be extracted from cameras for comprehensive analysis beyond simple playback. By adding additional layers and connecting multiple cameras, it becomes possible to correlate objects across different video feeds, enabling sophisticated analytics such as origin-destination mapping, route choice analysis, catchment area studies, and trip origin analysis. Thank you for exploring Project Hyrax with us. We welcome your questions and feedback as we continue to develop and refine this technology.